Alright, hey guys, Mr. Kyle, Myers Mathematics, and let's dive into what I have to talk about today, which is how to solve any trig identity. So I have a few practice problems here that we're going to look at, but before we do, I want to go ahead and lay out the steps for you, and I'm going to kind of just type them out over here, and we'll look at how those play out when we actually try to solve problems. So let's move this text box over. And here's basically how this goes. You kind of want to treat it almost like you're going to go to a nice restaurant and eat. All right, so step one is the appetizer. All right, step one is the appetizer. Here's what you want to do. You want to look for Pythagorean theorem identities. All right, so you want to look for squared stuff. Look for squared trig stuff. That's what you want to look for. Look for squared trig stuff. All right, so we're going to use either sine squared plus cosine squared, right? So any of the three Pythagorean theorem identities. They're called the Pythagorean identities, but that's because they're based on the Pythagorean theorem. So that's going to be sine squared plus cosine squared equals 1, tangent plus 1 equals secant squared, squared, everything squared. And then the other one as well. So the way you can get them is you can either set up a Pythagorean theorem, x squared plus y squared equals r squared, and then divide each one by either x squared, y squared, or r squared. You can do it that way, or you can just, I don't know, memorize them. There's a couple different ways, and you can look up like songs on it and stuff, just however you need to memorize them, or you can maybe ask your teacher and see if there's a formula sheet. If there's a formula sheet and this is on there, then you don't have to worry about it. But here's the Pythagorean theorem on the xy axis. And this is what I mean by getting the formulas by dividing. So this is the Pythagorean theorem. If I divide each of these things by, let's say, r squared, the equation is still balanced because I just divided both sides evenly by r squared. X over r, aka adjacent over hypotenuse, is cosine. Y over r, that's sine, that's opposite over hypotenuse. And anything over itself is 1. So there you go, there's one of your equations. And of course, sometimes I don't put these little thetas in here. But, you know, technically they do exist right there. I just don't like to write them because I think it's a waste of time. So cosine squared plus sine squared equals 1. That's one of them. And then you can get the other two, because there's 3 Pythagorean theorem identities. You can get the other two by dividing by either x squared or y squared. And then just remembering your SOHCAHTOA, right? So that's step 1. That's the appetizer. Next we have step 2. All right, so I'm going to move this down. Let's put him right here maybe. Step 2, you have your main dish and your side. So side and main dish. Okay? Side and main dish. This is when you're going to look for stuff that's multiplied, or I should say, I'll just write it out. Multiplied, if I can spell it. Here we go. Multiplied or divided. Whew, spelling. So look for stuff that's multiplied or divided. So, you know, for instance, in number 1, tangent times sine, there could be something there. There could be something I could do with that if I like change sine and cosine around. Yeah, so anyways, we'll get to that in a second. But we want to look for stuff that's multiplied or divided. Okay, so when I say that, I mean we're going to use the reciprocal identities. Reciprocal and the tan equals sine over cosine identity. And all of its different forms that you can get by using reciprocal identities. So for instance, tangent equals sine over cosine. But if tangent is equal to sine over cosine, then that also means that 1 over tangent would be the reciprocal of that, which would be cosine over sine. And we know that 1 over tangent is actually cotangent. And if I flip cosine, cosine's reciprocal is secant, sine's reciprocal is cosecant. So there you go. There's like a couple different formulas right there. Okay? So you can flip it around using tan equals sine over cosine. You gotta remember that one. So it's super, super important. And then you can use the reciprocal functions to change that around. Or just a reciprocal function by itself. Like cosine is 1 over secant. Something like that. Right? So step 1, appetizer. Step 2, you want your side and your main dish. So you're going to look for stuff that's multiplied. Okay? And then we have the last and final step. Oh, my text box went away. Hey, there we go. Got it back. Step 3 is dessert time. So for dessert, we want to look for miscellaneous stuff. So you want to look for like sum and difference, formulas, and you could also do double angle formulas, which are basically sum formulas, but the sum of alpha plus alpha or a plus a. Double angles, half angles, half angles. There's no spell check on this, so I gotta be careful. Don't want to spell some weird words that don't exist. Double angles, half angles, and all the other lovely things that they could throw at you. Okay? So, for instance, the double angle formula for cosine has 3 different forms. Well, 3 main different forms, I guess I should say. But cosine of 2 theta is equal to cosine squared theta minus sine squared theta. So it kind of looks like a Pythagorean, but it's cosine squared minus sine squared. So it's like, it kind of seems like an appetizer. It's like a dessert appetizer, okay? The cosine double angle formula. So if you see cosine squared minus sine squared, that's going to be one of those. If you see squared stuff and you can't get it to fit into an appetizer, that means it's probably going to be one of the cosine double angles. All right, the cosine double angles are squares, so they look kind of like appetizers, but they're not. They're desserts. All right, don't get your dessert and your appetizer mixed up. Okay, you want all 3 things. And then when you've gone and looked at appetizer, main dish, and dessert, if you still are not full, meaning the problem is not done, then you rinse and repeat. You go back to your menu and you look at appetizers, main dishes, and desserts again. Right? So step 4 is if the problem isn't done. If I can move this box, that'd be great. Come on. Why you no move? There we go. So if you're not done, if not done with problem, this is some great English right here, y'all. If not done with problem, aka you're not full. All right? Then repeat steps 1, 2, y 3, and 3. Repeat steps 1, 2, and 3. You just kind of rinse and repeat. And you just keep doing that until you're done. All right, so the main things you're going to want to look for are squared stuff, aka the Pythagorean Theorem identities. Then you look for side and main dish stuff, because most of the work that you do for a lot of these problems is going to deal with using reciprocal functions tied into tangent equals sine over cosine. Okay, basically tan equals sine over cosine, and then you can use reciprocal functions to make like 12 different equations. Okay, there's a lot of different equations you can make. And then you look for desserts. Okay, double angle, half angle, that sort of thing. You'll be able to spot a double angle or a half angle fairly easily, actually, because if there's something other than x or theta in the problem, then you'll probably be using a dessert. Okay, so that's how you spot your desserts. You're going to be looking for, right, so maybe I should add this in here. Come on. So you want to look for 2x or 1/2 x, or that sort of thing, right? It could be theta, it could be some other letter, like they use y for question 5, okay? So just look for that sort of thing. I'm going to move this up a little bit, so he's kind of in the way of that work there. And there you go. You have essentially a 3-step process, but you just need to rinse and repeat. You know, if you haven't found just the right appetizer, or maybe you want 2 appetizers. You know, maybe the appetizers are pretty appetizing. Then there you go. So let's go ahead and look at problem numero uno over here. I'm going to zoom like way in. Oh, I don't want to move this over actually. Okay. So we want to, step 1, look for squared stuff. There's no squared stuff. All right, so no appetizers, at least for right now. Step 2, we want to do some reciprocal stuff. So basically, sine, cosine, and tangent are all like one side. They're like the Jedi. And then you have cosecant, secant, and cotangent, which are like the Sith. So you want to either have Sith or Jedi only. You don't want to have a mix, otherwise they're going to fight and you're not going to solve anything. Okay? So secant is a Sith, tangent and sine are both Jedi. The answer is actually a Sith. I don't know if you see that there. It's the answer is actually a Sith. It's 1 over secant, which is cosine, but the answer is 1 over secant. So we probably want to turn everything into Sith, or you can turn everything into Jedi. I kind of like to turn everything into Jedi because you usually are familiar with the Jedi first, and then you learn about the Sith. And I like to try to, you know, stay on the light side of things, you know. I don't want to go to the dark side. Even though they have cookies, I want to stay on the light side here. So secant x is 1 over cosine. And I'm going to leave out the x. I always do that just because I think it's a waste of time. So secant is 1 over cosine. That's a reciprocal identity. Tangent is sine over cosine. And then that's multiplied by sine. Okay, I am getting somewhere here. Let me turn my phone off. It's going to ding on me here. So I am getting somewhere, because now I have cosine and cosine, and see the answer only is like one thing here. The answer is just one thing. So if the answer is just one thing, then I probably need to like put this stuff together at some point. Well, I can add these now that they have the same denominator. I can say 1 minus sine times sine is sine squared over cosine. Oh, okay. So then I go to the dessert, and there's still no dessert because I don't have a 1/2 x or a 2x either on the left or the right side. So I don't really have any indication that I should be looking for dessert. So I'm actually going to go back to appetizers. Appetizers have arrived because 1 minus sine squared, that's got a 1 in it, and it has a squared thingy in it. If it has the 1 and the squared thingy, that's probably one of my trig functions. All right, so the one that I actually showed you was cosine squared plus sine squared equals 1. Okay. Well, either I can solve this and make it 1 minus sine squared and then plug it in to here, or I could just, since it's already equal to 1, I could just say, oh, well, this is 1 right here. And I'll just say that's cosine squared plus sine squared. All right, so that's 1. That's equal to 1, so I'm just kind of subbing 1 for cosine squared minus sine squared, cosine squared plus sine squared. Then minus sine squared all over cosine. Well, then what happens is I don't really need this parentheses, so that cancels. And I have cosine squared over cosine, which is cosine. It's just cosine squared over cosine, so I get 1 cosine to go away there, 1 cosine to go away there, and I have cosine. Well, cosine, if I flip it using the reciprocal identity, and I want to do that because I'm looking at the answer, and I'm like, hey, I don't have the answer yet. What's up with that? 1 over secant. And then I'm done. Let's add that x back in there, just for good measure. And there you have it. You look for appetizer, then you go to side dish and main course, and then you look for dessert, and then you go back and rinse and repeat. And that's how you do it. And I'll go ahead and solve some of those other ones here as well. Let's see if I can move this without moving the box. Haha! Okay. And let me decrease the pen thickness because that was a little bit annoying. At least for me. Let's see. Yeah, let's go down to the least thickness because I'm really zoomed in here. Okay. 1 plus cosine over sine is equal to cosecant x plus cotangent x. So notice on the left side I've got like 1 fraction. This is like 1 fraction. Oh, that's much skinnier. Over here, I've got two things. Uno, dos. I've got two things. So I probably need to split up my fraction first. Since I have two numerators and one denominator, I can do that pretty easily. This will just be 1 over sine plus cosine over sine. Okay. Well, 1 over sine is cosecant, so that wasn't too bad. Oh, not CSS. Pretty sure that's a computing language. Cosecant x. And that probably means that cosine over sine is cotangent x. But if you weren't sure and you wanted to check, you should know this one by heart. Tangent is equal to sine over cosine. Okay. Well, if I flip tangent to cotangent, then I would have to flip sine and cosine, and it would be cosine over sine. So there you go. It does work. Plus cotangent. And we're done. That's it. It actually wasn't that bad. It was much easier than number 1. Excuse me. It's like a hiccup. Okay. Número 3. Let's see. So we have a secant sine over tangent plus cotangent. Oof. One big old ugly fraction. And it's equal to sine squared. So there could be like some Pythagorean stuff going on because this is Pythagorean-ish. It's got sine squared in it. We're not going to be using double or half angle formulas, so no dessert. Sorry, we're going to have to skip out on dessert on this one. Let's start with the appetizer. Well, we're probably going to have to use Pythagorean at some point, but on the left side, if I try to make the left look like the right, normally you try to make the uglier thing look like the nicer thing. That's usually how plastic surgery goes, I think. So we want to make the ugly side, the left side, look like the right side, okay? So we want to probably start with the main course and side dish kind of stuff here. So let's change secant. Let's get everybody on the Jedi side. All right, we've got a couple Sith mixed in here. Secant is 1 over cosine times sine over 1. Let's just write that as a fraction too while we're at it. And then I'm thinking maybe we can get everything in terms of sine and cosine. Why not? Tangent is sine over cosine. Cotangent is cosine over sine. Okay. That could be just more sloppy, but no, everything is in sine and cosine form. So maybe that's helpful. I don't know. Let's multiply this fraction. Let's get all this fraction stuff. We just kind of turned it into a fraction on a fraction, so it looks really ugly now. But you know what? Sometimes when you do plastic surgery, I think you probably have to make things look uglier before you can make them look better. I don't know anything about plastic surgery, but I'm just making it up as I go here. So if I multiply by cosine and sine, I can get rid of the extra denominators and still have everything in terms of sine and cosine, which I probably want to do since my answer is sine squared. So I want to get rid of anything that's not, dark side stuff or tangent, all that. So let's see. This would be cosine would cancel. That would be sine squared. Ooh, hold on. That's sine squared. Ooh. Okay, so maybe all this bottom stuff turns into 1. So let's see. That would be cosine. I'd have to distribute this. So it would be all of this times that. So the sines would cancel and it'd have cosine squared. And then all of this times that. The cosines would squared and then I'd have sine squared. Oh, look at that. Oh, it was Pythagorean identity. Because look at that. Cosine squared plus sine squared. That's 1. And there we go. Equals sine squared theta. All right. So that's all you have to do. You just go down the list. Start with an appetizer. Move on from there. All right, here. We have these two things equal to 1. So again, I'm probably going to need to add these fractions together, right? So I want to add these fractions together. Probably want to make the denominators the same. That's usually how you add fractions, I think, right? So cosine, cotangent. We want to do a main course here because I don't see any squared stuff. We're probably going to have some squared stuff, but I don't see any squared stuff right now. So we're skipping appetizer, going straight to the main course. Right? Cotangent is cosine over sine. So that means 1 over cotangent, which is what this is. It's down here in the bottom. would be sine over cosine. So this would be like tangent times 1 over cotangent is another way to write that, right? Like tangent over cotangent would be tangent times 1 over cotangent. So anyways, this would be equal to sine over cosine. So this is tangent, not TAS, tangent sine over cosine. There we go. And now we can subtract. I made the denominators the same. Look at that. Why did I write a theta? So useless. Let's get rid of that. Okay. Now we can put them together. And that's really helpful because I want the answer to be 1, and the answer can't be 1 if I have two things. So I want to, put some things together here. So I have secant minus tangent sine over cosine. And somehow all of that's supposed to cancel. Well, somehow the top is supposed to equal cosine. Because if you think about it, if this equals 1, right, if I were to multiply both sides by cosine, then that top is supposed to equal cosine. So let's see. There's a couple things we could do. We could write secant as 1 over cosine minus tangent is sine over cosine. So that would be sine squared over cosine. I think that would work. Yeah, that would work. So this would be this over cosine, and then that would be 1 minus sine squared over cosine. So then I could do, sorry, I'm getting a little sloppy here. I could do keep, change, flip, 1 minus sine squared over cosine times, this is cosine over 1, so this would be 1 over cosine. 1 minus sine squared over cosine squared. 1 minus sine squared is cosine squared because cosine squared plus sine squared equals 1. So this is, I'm running out of space here, sorry. Cosine squared plus sine squared is 1. So that would cancel. Cosine squared over cosine squared is 1. Whew! There might have been an easier way to do that one. I feel like that took a lot of steps. Sometimes you see something and it takes less steps. I kind of just do stuff until I get the answer. So I actually don't always find the fastest answer. But you don't need to find the fastest answer, you just need to get the answer. Okay? If you want to be super big brain, then I guess you could aspire to finding the answer faster. But I'm like, all right, well, I'm just going to try some stuff and see what happens. So I'm waiting for this to stop lagging on me here. It's like definitely lagging. But for number 5, I'll go ahead and just look at it while it's trying to figure out its life. Cosine squared y, I don't know why they're using y, but they're all y's. There's no 2y or half a y or anything like that. So since there's none of that kind of stuff, no appetizers, or desserts I mean, and since there's no dessert kind of stuff, then we just do appetizer and main course, and that's it. So for this one, why is it still lagging? Come on. It's like frozen on me over here. That's annoying. But anyway, so we'd have cosine squared minus sine squared, which is actually a double angle formula. Oh, hey, it finally decided to load. Goodness gracious, that took forever. Okay, let's see here. So we have... Oh, yeah, I guess that's fine. Did I move this? Alright, so I think that's... Let's see. Yep, it's still being really laggy. Alright. Well, anyways, for number 5, cosine squared minus sine squared is actually a double angle formula for cosine, but so is 1 minus sine squared. And you wouldn't actually have to know that to solve this problem, because like I said, if you don't see 2x, or in this case 2y, if you don't see 2y or 1/2 y or anything like that, then you don't have to use double angle or half angle formulas. You could, in this case you could, because both of those things are equal to cosine of 2y. But we don't have to. And actually there's a 1 here, so we would just do cosine squared plus sine squared and just move it around like that. For number 6, cosine squared, tangent squared, minus 1 equals tangent squared. Again, that's an appetizer, straight up. There's a bunch of squared stuff and there's a 1. So that's definitely an appetizer. You definitely want to have an appetizer on there before you have a potential main course. And number 6, you might even just have an appetizer, and that's it. Okay? So I would go ahead and solve number 5 and number 6, but I feel like it's being really laggy all of a sudden, and that's really annoying. So I'm going to go ahead and end the video for today. And if you thought this video was super awesome, then you should definitely like and subscribe. And if you haven't gotten my awesome free guide, it's called The 5 Math Mistakes Everyone Makes and How to Avoid Them, and it's on my website, myersmathematics.com. Same name as the channel. And awesome. It is almost Christmas at the time of this video, so happy Christmas, y'all. And I'll see you in another episode.